Hello everyone, my name is Catherine Witherspoon and I am a graduate student in the UW-Madison Astronomy Department. So I work with Eric Wilcox in studying how star formation can be shut down in low-mass galaxies. So those are galaxies that are smaller than our own Milky Way galaxy where we live, and they're about the size of the Large Magellanic Cloud or the Small Magellanic Cloud, those clouds that you might see in the sky in the southern hemisphere. This is one way that we can actually look at how some of the most prevalent galaxies in our universe evolve over time. So in order to form stars, you need some really cold, dense gas so that if a galaxy stopped forming stars, it might run out of this cold, dense gas, or it might have a flyby with a nearby galaxy. The galaxy could run into another galaxy. And that's one way to remove the gas from the galaxy, again, shutting down star formation. But instead of removing the gas, you could also have the gas be heated by nearby stars as they're forming, or you could have an actively accreting supermassive black hole, where a lot of stuff falls onto this infinitesimally small point in space that has millions to billions the mass of our sun. And because these stars don't form from hot gas, again, you would be shutting down star formation. So it's actually this last mechanism for shutting down star formation that I find the most interesting. And it's because it's only in the past decade that we've actually discovered a lot of these actively accreting supermassive black holes in low-mass galaxies. So for a while we thought these types of black holes were actually only found in the most massive galaxies, even more massive than our own Milky Way galaxy. But now we know they exist, and so it's actually they exist in more than just a few galaxies. We can actually start to study how these supermassive black holes that are sucking in a lot of stuff, how do they affect the evolution of these low-mass galaxies? And that's where my research comes in. So I use telescopes around the world to look at how much gas is in these low-mass galaxies and determine how quickly stars are being formed. And so by comparing the properties of these galaxies with these actively accreting supermassive black holes to the galaxies that don't have these black holes, we can start to understand what the impact of these supermassive black holes is. And so is it heating its surroundings like we might expect, or is it ejecting gas from the galaxy, removing the gas? Or does it have absolutely no role in the evolution of the galaxy? We don't know, so we need to find out. There's one small problem though, and I might have mentioned it a little bit earlier. The star formation rate can be affected by the galaxy's environment density. So that is how many galaxies are nearby. The more galaxies that are nearby, the more galaxy interactions or flybys you might have. And so the more likely it will be that the gas in these galaxies will be removed. And then the star formation rate of the galaxy will be lower. So if we really want to determine whether these supermassive black holes can be responsible for shutting down the star formation rate, we need to just study the environment of these galaxies with the active supermassive black holes. And interestingly, we're finding that low-mass galaxies with these active black holes that also have lower amounts of star formation are located in lower density environments. So another way to say that is, if you have a low-mass galaxy and there's an active supermassive black hole in it, and the star formation rate is really, really low, so not very many stars are being formed, you can probably expect that galaxy to have very few neighbors. But this brings up a huge question of what shut down the star formation if it wasn't caused by the environment of the galaxy. So this is ongoing research, and we definitely can't say whether it is the presence of this active black hole that's shut down the star formation. But the rest of my thesis will look into this problem, and I'm looking forward to trying to figure this out. Just for one brief look at the galaxies that I've been looking at, they are very different from the galaxy I was showing before. It is not a nice spiral galaxy, nice pretty blue. They're mostly blobs, but you do see some structure in them, some small spiral features. So with that, if you have any questions, feel free to contact me through UW Space Place, and thanks for listening.